Hey everyone and welcome back to PrepFusion. I'm Anish and today we'll start the lecture 7 of AC to DC converters. So up until now we have studied half wave rectifiers, full wave rectifiers with our RE load. Now in this lecture we'll analyze full wave rectifiers with inductive RL loads, RLE loads, okay? And obviously we will take few assumptions in case of RL and RLE loads. I will explain as we go along. So first we'll analyze the inductive load. So in case of inductive load, right, what we'll analyze for the two cases here, like for the uncontrolled case as well as the controlled case. Uncontrolled case is what, when my alpha is equal to 0. We'll analyze them separately here because the separate analysis is actually needed. The separate analysis is actually needed, right, for alpha equals to 0 degrees. So we'll analyze these both things. So here is my inductor. And initially what my assumption is, inductor is unenergized, so obviously the current through it will be 0 and the rate of change of current will also be 0 because it is constant. Hence the voltage across it initially will also be 0, but it can change instantly. So first case will be for like first of all, if all of them are off. If all of them are off, like the things will be same, that VT3 and VT4 and VT so this, right, this will be VT1 plus VT2 actually. VT1 plus VT2 and VT2 3 plus VT4, all of them are off. So I can easily identify the region of forward blocking mode. What is the region of forward blocking mode? In case of T1 and T2, it will be from 0 to pi, and then it will be negative. And in case of T3 and T4, it will be negative, and then it will be positive. Okay, negative and positive, right? So this is pi, this is 2 pi, 2 pi. What is my region of forward blocking mode? What is my region of forward blocking mode? Region of forward blocking mode is what? It is basically, this is my region, right? This is the region of forward blocking mode. This is the region of forward blocking mode for T1, T2, and this is the region of forward blocking mode for T3 and T4. Okay, so in this region I will trigger my SCR T1 and T2, and in this region I will trigger my SCR T2 and T3. And if you want to see the voltages, right, here if you want to compute the voltages, basically what will happen? Initially this inductor has 0 current, hence the rate of change of voltage is also current is also 0, hence this will be grounded, and like I will assume this as ground, and if this is ground, right, this is also 0, right, this is also 0, or I don't need to assume ground here. What I can do, I can simply apply a KVL. So I can start from this point, minus Vs plus VT1 plus VT2 equals to 0. So what can I say? VT1 plus VT2 will be equals to Vs. Similarly, VT3 plus VT4 will be equals to minus of Vs. Okay, this will be negative and this will be positive. So these are the things, right? These are the things. And in the positive half cycle, my T1, T2 will be in the reverse forward blocking mode, and T3, T4 will be in the reverse blocking mode. In the negative half cycle, T1, T2 will be in the reverse blocking mode, and T3, T4 will be in the forward blocking mode. Okay. Now let's start with this. Let's analyze this. So analysis of converter at alpha equals to 0. So if like I'm analyzing this for the part A, that is for the uncontrolled case. Okay, for the uncontrolled case. Now at omega t equals to alpha, that is omega t equals to 0, SCR is triggered. So this is just like a diode. T1, T2 triggered. So as soon as this T1 and T2 are triggered, right, what will happen? What will be my VO? VO will be simply equals to Vs. So Vs will just increase and VO will also just increase, and it is finite. Inductor can change its voltage instantaneously. So like the VO will also increase slightly. So as my VO increases, right, what will happen is that this is positive. As this is positive, what can I say? My IO will increase. Okay, my IO will increase. So in this case, what will be the value of my IO? I know, right? My IO is what? IO is simply equals to integration of 1 by L integration of VO of t, okay, because it is across the inductor itself. So it will be Vm sine omega t d omega t, okay, not d omega t, this will be dt, because that is what is present in the formula. So this will be 1 by omega L. Now here, right, remember I am going from 0, omega t equals, this is dt equals to 0 to what, dt equals to this will be, let's say some value t, at any point, any time t, what will be my current. So this will be like you have to take the initial condition as well, that at t equals to 0 the current is 0 across the inductor. That we will take care of. This will be simply what, this will be here outside Vm will come, this will be 1 and this will be minus cos omega t. This will be at omega t equals to, at t equals to 0, what is happening, this is 1, this is 1, so this gets cancelled and I'm only remained with 0, okay, I'm remained with 0. So in this case we have to take care of the power flow as well now, right? So from where to where the power is getting flowed. So here if you observe it carefully, currently what happens, my Vs is positive. What is my Is? My Is, right? Is is equals to IO. Hence, what can I say? What can I say? I can say that my like Vs is positive because it is on the positive half cycle, and my Is is also positive, right? Because like this is, IO is always positive. It can never flow in this direction. IO will be always flowing in this direction, and IO is increasing. So both of them are positive. That means what? Power is getting flowed from the source to load. Because this time, right, what is happening? My inductor is getting energized. Why is my inductor getting energized? Because IO is increasing. IO is increasing. DIL by DVL. Sorry, yeah. What do you mean by that? Sorry, LDIDT, right? As my inductor voltage is positive, then obviously it is equals to LDI by dt. Hence, it is like the slope of the current is positive. Hence, current is increasing. So power flows from source to load. Okay, this time load is only inductor. Fine. And at omega t equals to pi, I will get the maximum value, because after that my voltage will be negative. Okay, as my voltage becomes negative, what will happen? Voltage is negative, and if the current is positive, that means the source will absorb power. Now it will not deliver power, it will absorb power. So what will happen here is that I will just take another page, because I need to take another page. At omega t equals to pi, what will happen is that at omega t equals to pi, basically this, right, current value will be what? IO. This will be the maximum value, because after that inductor will discharge. Why? I will explain in the next slide. So at omega t equals to pi, we put pi here, right? What will happen? This will be -1. So -1 into -1 is +1. So this will be 2 Vm upon omega L, and this will be the peak value. This will be the maximum value. After that, current will reduce. I will explain just in a bit in the second cycle. Right? In the second cycle, from pi to 2 pi, again what happens? I trigger my, okay, sorry, this will not discharge here. That also I will explain. So that case is that case will be in the second example, not in this, not in this case. For alpha equal to 0, it will not discharge. So at exactly omega t equals to pi, what is happening? My SCR T3 and T4 are getting triggered, right? My SCR T3 and T4 are getting triggered. So as these two are getting triggered, obviously what will happen? These two will turn on, and if these two turns on, right, they will naturally commute these two, because the potential across them will be what? If we just measure the potential, it will be VT1 will be VT1 equals to VT2 equals to minus Vs. You just apply the K, sorry, not minus Vs, plus Vs only. You just apply the KVL and you will understand, which is less than 0. Hence, automatically my thyristors T1 and T2 will go in the reverse blocking mode. My thyristors T1 and T2 will go in the reverse blocking mode. Now here, what I can say is that again, what is my VO? this time, right, if you apply KVL, VO is basically, if I start from here, okay, I will start from here. This is plus VS, then plus VO equals to 0. So VO is equals to actually minus VS this time. VO is equals to minus VS. And what is VS? In this cycle, right? In this cycle, VS is actually negative. VS itself is negative, right? VS itself is negative. So obviously, VO will be positive. VO will also be positive. VO is positive. If VO is positive, that means what? My del IL by dt is greater than 0. That means again my current will increase. Current will not decrease. I'm sorry for that. It will increase. So this is not IO max in this case. Okay. Sorry for that. It will not be IO max. Okay. So current will increase again. And what will be the expression for current? I will just write down the expression for current. Again, same. IO is equals to what? 1 by L integration of minus Vs this time, because it is VO and VO is minus Vs. So it will be minus Vm sine omega t dt, and I'm starting with pi and I'm going for some time t. Okay, so this will be Vm by omega L, and this will be basically cos, this will be 1 plus cos omega t. One small mistake I have done here is that this should not be pi, right? This should be pi by omega, then only they will get cancelled, because I am placing limits of what? Lower limit and upper limit of dt, right? Not d omega t, because that is in the formula. VL is equals to L di dt. If I integrate on both sides, I have to integrate with respect to dt, not omega t, because whenever I used to integrate with respect to omega t, right, that was just the x-axis was omega t. That's why I did that. But here I have to integrate with respect to dt. So these are the limits of time. So here this should be pi by omega, because at t equals to pi by omega I'm starting. Okay, and this is at omega t equals to pi. So t is equals to what? T is equals to pi by omega. Okay, that is the thing. So that's why this will be simply 1 plus cos omega t. And if you put here omega t equals to pi, what do you get? At omega t equals to pi, okay, am I doing something? Okay, this should be negative, right? This should not be positive. This should be negative, because like if you do the integration, this should be negative. Just a silly error on my part. So at omega t equals to pi, this is minus 1. So minus of minus 1 is 1, and this is 2. So 2 Vm upon omega L, which is matching here. So initial condition is matching for this inverter. Current doesn't change instantaneously. So current is still omega t equals to pi plus is also this same 2 Vm upon omega L. Can you tell me what is the direction of the like power flow? What is the direction of the power flow? So if I take another page, okay, if I take another page, I know Vs is negative, but what about Is? What about Is? So my Vs is negative. Okay, what about Is? What about Is? So Is, right? Is. What is Is? So here, right, in this thing, like IT1 is 0. So Is is equals to minus IT4. Is is equals to minus IT4. And here, what is the value here? So here, right, IT2, like IT2 is 0 and IT4 is coming like this, and IO is coming. So incoming should be equals to outgoing. So IT4 is this and IO is this. So IO is equals to IT4. IO is equals to IT4. So I will just replace IO here. I will just replace like IT4 here with respect to plus IT4. So this will be minus of IO. So this is minus of IO. Hence, what do I understand from this? What do I understand from this? So here, right? So here, important point is IO is positive. IO is greater than 0. Why? Because we just derive the value, and IO cannot suddenly like make its voltage not make its current in the opposite direction, because I'm applying a finite voltage, not a infinite voltage. So here IO is positive, but Is equals to minus IO. So my Is equals to negative. Is is negative. So if Is is negative and Vs is also negative, so Vs into Is, that is power, right? Instantaneous power is actually positive. Okay, because negative times negative is positive. So again, what is the direction of the power flow? Direction of the power flow is from source to load. So in both the cycles from 0 to pi and pi to 2 pi, the power flow direction is from source load. So what is happening to the current? So basically current, right? So current is just keeping on increasing. So from 0 to pi it increased to, let's say, this value 2 Vm upon omega L. This is pi. From pi to 2 pi, pi to 2 pi, this is 2 pi, right? This is what? Four Vm upon omega L. Why is it upon 4 Vm upon omega L? You just place here, right? You just put here 2 pi. In this equation, you put 2 pi. If you put 2 pi here, what will be this value? So, okay, am I doing something wrong here? IU of t plus this, so at omega t equals to pi, this is minus 1, okay. This can 2 pi also, this will be plus 1, this will go to 0, okay, this is not actually reducing, okay, my fault. So 2 pi, this should be right, here I should have a value. Okay, I made a mistake here, this should be plus omega t, and if this is plus omega t, right, I have to add the initial condition as well. What is the initial condition? Initial condition is 2 Vm upon omega L. So initially this was 2 Vm upon omega L. This integration I did a bit of mistake on my behalf. This should be actually plus. I made a mistake over here. So if I put omega t equals to pi, right, this becomes 0. So I need to add the initial condition. What was the initial current? That is at omega t equals to pi, it was 2 Vm upon omega L. So this will be the initial current. So now everything is perfect. So now if I put 2 pi here, right, this will be simply 1. If there is 1, so 1 plus 1, 2 Vm upon omega L and 2 Vm upon omega L. So every pi period, the current is increasing 2 Vm upon omega L. Okay, this should be 2 Vm upon omega L. This is 3 pi, and like this will be 6 Vm upon omega L, and it will keep on increasing. So hence it is unstable, and obviously it is not possible for inductor to carry infinite amount of current. So at some point, right, at certain point, like if you have studied machines, it will hit saturation. It will hit saturation. Okay, so this is what will happen for the inductor, because flux will saturate. Okay, so inductor has some like finite amount of flux that it can produce. So now let's understand the second case. Second case is what? When my alpha is between 0 to 90. Now this is in the control range, my alpha is between 0 to 90. So there will be multiple parts of analysis here. So in the case 1, between 0 to alpha, when my SCRs are in forward blocking mode, because I have already computed the forward blocking mode, which is 0 to pi for T1 and T2 and pi to 2 pi for T2, T3 and T4. So basically my IS will be 0 in the forward blocking mode because everything is off. Obviously T3 and T4 are in the reverse blocking mode, and T1 and T2 are in the forward blocking mode. So IS equals to IT equals to what? 1, 2, 3, 4, everything is off, equals to IO equals to 0 amperes. Correct. Now what is my VO? VO is simply equals to what? VO is VL0 minus, which is basically 0 because there is no change in current. So as there is no change in current, the output voltage also will be 0. So what will be VT1 and PT1 plus VT2? VT1 plus VT2 will be simply plus Vs because they are in the forward blocking mode. You can use the key, we'll understand that. And in this case, right, so it will be greater than 0, hence both of them will share the voltages and both of them will be in the forward blocking mode. Now just add omega t equals to alpha. Omega t equals to alpha. So at omega t equals to alpha, what is happening? This two SCRs T1 and T2 are triggered. T1 and T2 are triggered. So as soon as T1 and T2 are triggered, what does that mean? That means that T1 T2 are on, T1, T2 are on. Okay. T1, T2 are on. Now what can I say is that like what will be my VO output as soon as they're on, right? My VO will be simply equals to VS, which is positive. If this is positive, that means that my IL will increase, or IO will increase, right? IO will increase, and whatever I have derived in the previous case, that will be same here as well. That basically my IO expression can be written like this. It will be 1 by omega L 1 minus cos omega t. Okay, not 1, sorry, Vm. Okay, so this will be the IO expression. Okay, and in this case also, what is the direction of the power flow? Whenever inductor is present, you have to understand the direction of power flow. So power flow right now is from source to load. Power flow right now is from source to load. Okay, so this will be the value, but here this won't be 1 because, okay, one mistake I've done. Here, right, this will be cos alpha actually. Okay, one mistake I have done. This won't be until pi. Okay, because it will charge till pi. Fine, charge till pi. So this will be 1 minus cos alpha. Or am I doing this something wrong? No, this is correct only. Okay, this will be not. This will not be. Okay, what mistake I have done? This is omega t only. This will be cos alpha. Okay, so let me just write down the derivation because else you will get confused. So what is the value of the current? So I'm starting from what? I'm starting from alpha, not from 0 this time, because my SCRs are conducting from alpha. Okay, that's why. So alpha to t, and this will be alpha by omega here, right? This will be alpha by omega. So and this is 1 by L. Okay, integration of 1 by L, and this is Vm sine omega t dt, right? So if I derive this expression, right, what will be this? This will be simply IO will be Vm by omega L sine alpha minus sine omega t. Okay, so this is the case. Here. And this is the current, right? This is the current. And if you put omega t equals to alpha, at omega t equals to alpha, what should be the current? The current should be 0, because at that point only T1 and T2 are triggered. Before that, the current was 0. So inductor will try to keep the same current. So here, if I put omega t equals to alpha, this is not taken sign. I am making so many mistakes today. Sorry for that. So this will be cos only. So at omega t equals to alpha, if I put omega t equals to alpha, this will be 0. Okay, so whatever my assumption, that is correct only. So it is like satisfying the initial conditions. So why will the peak occur? Peak will again occur at omega t equals to pi. I will explain why. Okay, this time I will be correct. So if I just add a page here, okay, if I just add a page here and write this at omega t equals to pi. Omega t equals to pi, what will be the case? Omega t equals to pi, I will get IO max, because after that everything will discharge. So this will be Vm by omega L, and if I put pi over here, right, this will be plus 1. So this will be cos alpha 1 plus cos alpha. Okay, so this will be the value of the maximum current. So after this, what will happen is that if you observe here, then from pi to pi plus alpha, right, from pi to pi plus alpha, you will say, sir, this T1 and T2 will go in the reverse blocking mode. You will say T1 and T2 will be off as they are in the reverse blocking mode. I will say no. Why I will say no? I will say no because the reason is that this inductor, right, inductor will keep it on, because my T3 and T4 are still not triggered, so they are still not on, right? They are still not on. So T3 and T4 will be in the forward blocking mode. But what will happen is that this inductor, right, it will try to flow the same current, so it needs some path of current, right? So this T4 is off, so it will keep this T2 on. How will it keep it on? So inductor will keep T1 and T2 on by changing its own voltage such that it keeps T1 and T2 on. Okay, so it will not take this T1 T2 to reverse blocking mode. It will change its polarity such that the T1 and T2 are on. So as T1 and T2 are on, what will happen is that my VO currently will be what? VO equals to Vs only. VO is equals to Vs only, which is less than 0. Okay, and my IO is, again, IO will always be positive, although it will reduce. So what will happen is, if Vs is less than 0, what is happening? My IO will reduce, because Vs is equals to what? L didt, and as the L didt is negative, that means current is reducing. Slope is negative, current is reducing. So IO will reduce, but it will not obviously go to 0 instantaneously, it will reduce. So what can I say is that, what is my Vs is negative this time, right? Vs is negative, I've just proven Vs is negative. What about the direction of power flow? So in the case 3, my Vs is negative. So what about my Is? So if I observe here, Is is still equals to IU, right? Because these two are on. Whenever these two are on, so Is is still equals to IU, and I have just proven to you that IU is positive, although it is decreasing, but still it is positive. Okay, so IU will also be positive. So this is negative, this is positive. So what is my PS? PS, right, is equals to Vs up into Is is less than 0, negative. That means what? That means power is flowing from load to source. So power at this time, right, is flowing from load to source. Why? Because the source power is negative. That means it is absorbing. Okay, and if you compare the load power, right, load power is also negative, because VO is negative, right? VO is negative, hence load power is negative. That means it is delivering. The negative power of load means delivering, the negative power of source means absorbing. Okay, so I hope you understood these points. Or you can see that it will change its polarity, right? So current is leaving from this, and here, right, this will also change this polarity. So current will enter the positive polarity, this will absorb, this will deliver. Okay, so just with sign also I told you, just with this mathematical foundation also I have told you, mathematical background. So here what is happening in the case 4, right, at this I already had extra page for this. Okay, at omega t equals to pi plus alpha, what will happen? Omega t equals to pi plus alpha, basically this T3 and T4 will be turned on. T3 and T4 will turn on, and as soon as they turn on, right, they will, like, T1 and T2 will be naturally commutated. T1 and T2 will be naturally commutated due to T3 and T4. Why? Because as soon as T3 T4 turn on, the voltage across the resistors will change. They will be negative, and as soon as they go to negative, they will be off. Okay, so in this T3 and T4, right, as soon as they on, inductor will again charge. Okay, inductor will again charge, because there is another reason that inductor, right, it doesn't want to lose its energy. So previously it was losing its energy. As soon as T4 and T3 will turn, it will like that gains its energy, so it will keep these T3 and T4 on and this T2 and T1 off, because it also wants to gain energy. Everyone wants to gain energy, right? That's why. So here again, what will happen? What will my VO, right? If you apply the KVL, it will be minus VS. We have done this many times before, so this will be minus VS. My IO is still positive. IO is still positive because still it hasn't totally discharged. It hasn't totally discharged. So what is the value here? What is the value of IO? So here, right, if I just write the value of IO, or it will totally discharge. It will not totally discharge here. So, or it will totally discharge. If I just write the discharge current here, right? So my VO is still equals to VS. So what will be expression for IO? IO is 1 by L integration from this time pi by omega to pi plus alpha by omega. Into Vm sin omega t dt. So this will be what? This will be 1 by omega L, and Vm is also there obviously. What will be this expression? This will be cos of pi, that is 1. Sorry, this will be on the right side, right? Okay, I will not do this till pi plus omega. This will be till t, some value t, right? Some value t. So this will be again minus. So what am I doing wrong? Minus of, so 1, yeah, 1 minus cos omega t. Okay, so if I put here omega t equals to pi, this is going for 2 Vm upon omega L. Any mistake I'm making here? Like this is the same case that I did for the previous one as well, right? Here is computing here. What did I make? Okay, this is minus piece. Okay, that's why this was different. So that's why this become plus only. But this time this is not minus. So okay. So where this will be minus only because like it is integration is minus sin omega t, so this will be minus and this will be plus. Okay, 1 minus cos omega t. Now if I put here omega t equals to pi, what is the value? Omega t equals to pi is simply 2 Vm upon omega L, which is not satisfying. Actually, I need this value. I need this value, right? Because this was the current at omega t equals to pi. Omega t equals to pi, current was in 2 Vm upon pi L. So I have to, like, Vm upon omega L should be equals to, at omega t equals to pi, what is this value? This is Vm upon omega L, 2 Vm upon omega L, 2 Vm upon omega L, and obviously I have to put here cos alpha, right? Cos alpha, 1 plus cos alpha, and plus some x value I have to add because that is the initial condition of integration, right? That is initial condition of integration. So here this 2 Vm upon omega L will go over there. So this will be cos alpha minus 1 Vm upon omega L. Yeah, this is correct only. So this will be my x. Okay, fine. So x will be this Vm upon 2L plus Vm upon omega L into cos alpha minus 1. So now, right, if I put omega t equals to pi, what will happen? This will become 2 Vm upon omega L. This will become minus Vm upon omega L. There will be only 1 Vm upon omega L remaining, and also Vm upon omega L into cos alpha. So yeah, this is correct, right? 1 Vm upon omega L is remaining and plus cos alpha. So this is correct. So here, this is the correct option. So this is correct only. So like, why did I do this? To actually write the correct expression, correct? Because with integration, whenever you do the indefinite integration, you get a constant of integration that is defined by the initial condition. So initial condition was this. So now, right, now if I put pi plus alpha here, if I put pi plus alpha, if you observe, if you put pi plus alpha, this will not totally go to 0, or this will go to 0. If I put pi plus alpha, so omega t pi plus alpha is minus cos alpha. So I will just do one thing. Copy this. Omega t equals to pi plus alpha. So one thing we know that cos of pi plus alpha is minus of cos alpha. Okay, this you can understand from trigonometry, or if you tend to forget, right, what you can do, you can write like it is. I have taught it in my network theory. You can write cos theta here. Okay, cos theta. So sin theta is always below this here, and my if I just add pi with it 180 degrees anti-clockwise, so I will be at here. What is this? This is minus of cos theta, right? This is minus of cos theta. So obviously cos of pi plus alpha will be minus of cos alpha. So here I will replace this, right? I will put here I of output current at, although you can understand this intuitively, obviously I will just explain you intuitively as well. I will explain you through expressions as well. So at t equals to pi plus alpha by omega. So what will be this? So this value, right? This value will be simply, what is this? This value will be cos alpha negative of it. So this will be 2 Vm upon omega L, and here this will be plus, obviously there is cos alpha here as well, and this will be okay, there is one Vm upon omega L as well, right? So okay, Vm upon omega L minus Vm upon omega L. This will be only the value. Okay, 2 Vm upon omega L will be the only value, because Vm upon omega L and Vm upon omega L, this is getting cancelled, right? This is getting cancelled, only this is the case. Minus, yeah, omega equals to pi, this is 2 Vm upon omega L, this is only this, so this is Vm upon omega L, yeah. So this will be my value of current at IO. So alpha, right? Alpha, what is my range of alpha? I assume that alpha is lying between 0 to 90. So if alpha is lying between 0 to 90, so this cos alpha will only go 0 at 90, right? It cannot go to 0. So this will be some value that is greater than 0. So I have proved here as well, and I will show you through the graph as well why this will not completely discharge. This will be greater than 0. Okay. Next, for the case 4. For the case 4, what is happening? At omega t is equals to pi plus alpha, T3, T4 are triggered, and this is the current, right? So this is the voltage. Now what is my IO? IO current will be what? Again, I will integrate this time, but this time I will integrate the negative value of Vs. This time I will integrate the negative value. So this will be 1 by L integration from what? Integration from pi plus alpha divided by omega to some time t. This will be minus Vm sin omega t dt. Okay. So now if I integrate, again the things will be a bit difficult here. Okay, things will be a bit difficult. So can I have to take care of the initial conditions as well. So this will be simply sine of pi plus alpha. So okay, this will be okay. This will be IO 0 will be Vm by omega L cos of omega t pi plus alpha by omega to 2 pi to time t. So here what is happening is that this is Vm upon omega L cos of omega t minus pi plus alpha by omega. So again I am adding some value pi plus alpha. It will be minus of cos alpha. This will become plus of cos alpha. And at omega t equals to pi plus alpha, what should be my current? Current should be 2 Vm upon omega L into cos alpha. But here, if I put pi plus alpha, this will be minus cos alpha. This will overall go to 0. So I have to add another value, that is 2 Vm upon cos alpha. This will be the constant value. Okay, this will be the constant value. Not upon, sorry. 2 Vm upon omega L into cos alpha. 2 Vm upon omega L into cos alpha. This will be the value, right? So this will be the current expression. And now, right, what will happen is it will charge again. Why? Because if you observe here, VO is equals to minus Vs. That means my VL is greater than 0. So if my VL is greater than 0, that means my IO will increase only. So IO will increase. So after this, like you can observe from the expression as well, You can observe from the expression as well. It is cos omega t plus cos alpha. So if I increase omega t, right, although okay, this thing is reducing, but current should increase, right? If I increase omega t, okay, in which region I am at? I'm from pi plus alpha to pi, and from pi plus alpha to pi, what do I know? I know that like in the second half cycle, right? In the second half cycle, cos actually increases. From this 0 to pi, cos actually decreases. Then after this, right, cos actually increases. Cos keeps on increasing. So cos will only increase after this. So that is the case. So this will be the current expression. And like in case 5, what will happen? In 2 pi to 2 pi plus alpha. Again, this SCRs T3 and T4 will try to turn off. Okay, SCRs T3 and T4 will try to turn off, but that will not happen. So again, what will be the power flow this time? If I forgot to draw the power flow. So power flow here, right, my Vs is negative, right? But one thing is that like in this region, right, my Vs is less than 0. So Vs is less than 0. In the negative half cycle, Vs is less than 0. What is Is? So Is, if I observe, right, Is is basically this value. So Is is minus of IT4, which is equals to minus of IO. So Is is minus of Is is minus of IO, which is again less than 0. Hence overall my power flow is what? Power, right? Power is again positive. Negative into negative becomes positive. So this is power flow. It will be again from source to load, because overall power is positive only. Okay. So now let's come to 2 pi to 2 pi plus alpha. So in 2 pi to 2 pi plus alpha, again you will think that okay, here the T3 and T4 will be off because they are in the reverse blocking mode, but no, right? T3 and T4 won't be off. They will be simply on, because the inductor will keep them on. Why? Because the inductor doesn't want to stop conduction, right? Because if T3 and T4 are off, and obviously I know T1 and T2 are in the forward blocking mode, they are not instantly on because they need triggering. So obviously the current will be 0, and if the current is 0, that is bad, right? Current cannot go instantly 0. A impulse voltage needs to be applied across the inductor. So what will happen is that the inductor will keep this T3 and T4 on for the same obvious reasons as I explained in the case 2, I think. Case 2, okay, or case 3, sorry, case 3, I think, case 3, right? So it will keep its voltage, it will keep T3 and T4 on, and T1 and T2 in the reverse will still be in the forward blocking mode. Okay, this time again my output voltage will be what? Output voltage is minus Vs. But what do I know about Vs? In this after 2 pi, right, Vs is positive. After 2 pi, Vs is simply positive. Okay, Vs is simply positive. So if Vs is positive, that means what? That means my VO is negative. If VO is negative, that means inductor voltage is negative. That means my current will reduce. IO will reduce. It is still positive, but current will reduce. And what is the another thing? This time also my IS is actually equals to minus IO, and IO is positive. But IS is negative, right? IS is negative. And my VS is positive, because after 2 pi my VS is positive. So overall, what is the direction of power flow? Power, right? PS is equals to Vs into Is. Overall this is negative. So again power will flow from load to source this time, because it is absorbing the power. Our source is absorbing the power. Okay, next, like this was the case that I wanted to write, but the same thing I have given extra page, so I'll just skip this. So if you are seeing the waveforms, right, so what will happen is that here, right, it will go increase up until pi, then again it will decrease and decrease at 3 pi by 2. Like I have assumed that my alpha is equals to 90. So if your alpha is 90, right, if your alpha is 90, if you choose here alpha is 90, what will happen? This current will be 0. This current will be 0. So it is on the edge of continuous conduction and discontinuous conduction. So just if your alpha is 90, then just at alpha the current total discharges to 0. Then again this T4 and T3 are turned on, and as soon as this T4 and T3 are turned on, again the inductor starts from 0. Okay, so I have taken the boundary condition. So this condition is the case where I am in the boundary of continuous and discontinuous conduction. Okay, I am in the boundary of continuous and discontinuous conduction for this particular case, alpha equals 90. Then your homework is what? Your homework is this: analysis of alpha greater than 90 and less than 90, what will happen is basically I will just show you the intuition that whatever amount it was charging, by how much duration it was charging, alpha from alpha to pi, that is total duration is pi minus alpha. So it will take that same duration to discharge. So total pi minus alpha. So if I add pi minus alpha with it, it will be 2 pi minus alpha. So up until 2 pi minus alpha, the current will go to 0 again. It will remain 0, and then again at pi plus alpha, what will happen? The ACRs T3 and T4 will be triggered, and as soon as T3 and T4 are triggered, again the current will slowly increase. So the amount discharge and charge, right? So here, this is the discharge, and this is the charge. So whatever amount it was discharging, it charged to, I wrote it opposite. It should be here. So it discharged the same period. Why? Because here, right? Why it will be same? Because charging period and discharging period will be same. Discharging period are same. Why is it the case? Because here, right, my resistance is absent, R is absent, right? R is absent. That's why this is happening. In the next analysis of the converter with RL load, this will not be happening. That's why this case won't also be happening, right? So yeah, this will always keep on increasing in case of unstable. So this, if my alpha is between 90 to 0 to 90, the circuit will always be unstable. If my alpha is between 9 equals to exactly 90, it will be in the edge boundary of continuous conduction and discontinuous conduction. If my alpha is between 90 to 180, basically it will charge and then discharge. So this will be discontinuous conduction, right? This will be discontinuous conduction. Okay, so discontinuous conduction. Okay, so these will be the 3 cases, and these are very good cases because this may come in examination. Some conceptual question can come in examination. Okay, so these are the key points. So for alpha greater than 90, the circuit will get stable operation, else it will get a unstable operation for a purely inductive load. And the peak current, right? Peak current will always occur at omega equals to n pi for stable operation. When we have stable operation, else current will obviously keep on increasing. Okay, so this is the analysis basically for purely inductive load. Now we will analyze for the full wave rectifier with RLE load. So we will study directly RL and RLE load together, and this will be simpler only, don't worry, because the procedure will be same. Separately you can derive for RL load. So you just put E equals to 0 for RL, right? For RL, just put E equals to 0. That's it, right? So here we'll obviously together consider controlled and uncontrolled. For uncontrolled, right, you put alpha equals to alpha minimum. In this case, alpha minimum will be again theta. Okay, will be again theta. Theta is this sine inverse E by Vm. Now here what will happen? Resistor is present. So as resistor is present, it will make the system stable, right? It will never allow the system to go unstable. So that's why resistors are actually also important. So as I will write here, as resistors are present, it will make the system stably. So here system won't go unbounded, system will be bounded only. So here what will happen, either the current will totally discharge, so it will be discontinuous, or it will be like continuous. So for us, right, first of all we'll assume continuous case, and then I will tell you that discontinuous case as well. What is the condition for it to be discontinuous? So what is the intuition? Intuition basically is that, let's say I am plotting the graph of IO, right? I'm plotting the graph of IO, and IO can never be negative. IO can never be negative because like current cannot flow in this direction, can only flow in this direction due to this SCRs. Now what will happen is, from let's say alpha to pi it will charge, or pi minus theta it will charge. Then from pi minus theta to pi plus alpha again it will discharge, because what will happen, this will be negative and this will be positive. Still the inductor will keep these SCRs on and this will discharge. So the current will be something like this. It will charge, then discharge, charge, then discharge, charge, then discharge. Now if the charging is very high and discharging is very low, so it will almost be constant, right? So this will be the case. So current will be like, we will be able to get constant current here. So this is the converter that we actually use in the practical life. So like this is just the intuition, this is just the intuition of IO. Now obviously we will analyze this part by part and there will understand what is actually happening. So again, first point is period of forward blocking mode. Again I will assume when all the SCRs are off, then what are the regions in which my SCR can go into the forward blocking mode. So these conditions can change as inductance is present in the load, but just let's first simplify things, then we'll complicate them later on. So if again the same thing that when all of them are off, my VT1 plus VT2 will be simply equals to Vs, and my VT3 plus VT4 will be simply equals to minus of Vs. Okay, so Vs is equals to minus of Vs. What will happen? This will be basically plus a positive sinusoid, and this will be a negative sinusoid, right? This is minus Vs, right? That's why. Okay, so and here this is E. Okay, and like why is this E? Because what is the potential? Now this is not equals to simply Vs, right? If I apply KVL, there will be a E as well. I forgot the E. This will be minus E and this will be plus E. Why this will be plus E? So if I just apply this KVL, right, simply for VT4, so I'll go from plus VT4 plus Vs, then plus VT3 and plus E. Okay, so everything is plus. So sorry, this will be minus here, right? This will be minus. Sorry for that. Minus E. Okay, so if I plot Vs minus E, right? Yeah, minus E will be somewhere around here only. Fine. So again, this will be the region for the forward blocking mode of T3 and T4, and this will be the region of forward blocking mode of T1 and T2. Okay, so I hope you understood what is happening when everything is off. Now we'll analyze this circuit, then only we will understand. So here alpha, from omega t equals to alpha to pi, what my assumption is, the current is continuous. So at alpha, right, at alpha, omega t equals to alpha, my T1 and T2 are triggered. triggered. Okay, so at omega t equals to alpha, T1 and T2 are triggered. So what is happening now? What is happening? This is on. So what is my VO? VO is equals to plus VS, and like what will happen is that my IS, I will assume IS is what? IS is simply equals to IO, and I will assume that IO is either 0 or it can be greater than 0, right? IO can be any value. IO is either 0 or greater than 0, so it can be either equals to or greater than 0. So my power, right? Power will be what? PS equals to VS IS. It can be equals to or greater than 0. So that means power can either flow from source to load or it can be 0. Okay, so I will assume it as greater than 0. So what I will assume is that power is flowing from source to load. This is my power. This is my power and source to load. Okay, so this is the power, and obviously my VO is positive, right? VO is positive as supply voltage is positive from in the positive half cycle basically. And what are the other things? Other things is that this current, right? This IO current is equals to simply my IT1 and equals to my IT4, and my IT3, sorry, not 4, IT2, and IT3 equals to IT4 equals to 0 amperes. Okay, so these are all the cases that we need to know. So obviously as power is flowing, right, I can safely say that my current will increase, whether be from 0 or some finite value, non-zero value. Current IO will increase as I am understanding that power is flowing from source to load, so the source is energizing the load. Now at pi, right, at pi what will happen is that inductor has some current, and at pi you will say, sir, T1 and T2 will go to natural commutation. T1 and T2 will go to natural commutation. I will say no. Why? Because if T1 and T2 goes into natural commutation, what will happen? The current will become 0. Okay, current will become 0, and inductor, right, it has some non-zero current. Okay, it cannot go to 0 instantaneously. So obviously it will change its own polarity to keep T1 and T2 on. Just explain as explained in the inductor case. So what will happen is that inductor, okay, where did I go? Here. Inductor will change its own polarity to keep T1 and T2 on, so that current doesn't go to go to 0 instantaneously. Instantaneously. Okay, so this is the case that is happening. So what will happen is that it will keep the T1 and T2 on, and if the T1 and T2 is on, then what will be my output voltage? Output voltage will be equals to Vs. Simply you can apply the KVL. And what do you observe is that my IO will be what? My source current will be what? Source current will be equals to IO. So source current is IO, which is positive, because I have assumed that there is some current through the inductor, right? I have assumed that there is some current through the inductor. That is what my assumption is. Okay, so if there is some current through the inductor, because it was charging, right? It was charging. Now if I apply the product, right, in this range, what is my polarity of Vs? Vs is less than 0, because Vs is negative. After pi, Vs is negative. It is in the negative half cycle. So what would be my power? PS is equals to Vs into Is, which is negative, because Is is positive but Vs is negative. So as Vs is negative, that means that this time what will happen? What will be the power flow direction? What will be the direction of power flow? Power flow direction will be from load to source, because this is negative. That means what? Source is absorbing the power. Source is absorbing the power, right? Absorbing the power. So source is absorbing the power. That is what I know. Okay, so next what can I say? Next what I can say is that as this is negative, right? So inductor will discharge. Why inductor will discharge? Because like source is absorbing power. Someone has to supply that power. Who will supply that power? Inductor will supply that power by changing its polarity. So obviously my inductor voltage is negative, okay, is less than 0, it will be negative, and hence my IL will reduce. Now there can be two cases here, IL and my, obviously IL is equals to IO, so IO will also reduce. There can be two cases. One case is that I have continuous conduction, so I have already assumed that till the next triggering happens, right, pi plus alpha, my IO will not go to 0. So this, right, this case means continuous conduction. Continuous conduction. That means when is the next triggering happen? When is the next time my inductor will get charged again? When T3 and T4 will be on. Okay. So if there is continuous conduction, right, I will assume that my current doesn't go to 0 up until this pi plus alpha. But for another case, let's take this extension angle beta, that current is reducing, and my assumption is at omega t equals to beta, the current goes to 0. So here, right, there is a discontinuous conduction, continuous conduction. And what should be the condition for discontinuous conduction? That whatever this extension angle I compute, right, this should be less than pi plus alpha, because just at pi plus alpha again my inductor is energizing, so current will increase only after that. So this is the condition. Okay, so what will happen? Current will reduce, and as current reduce, current, like I will write here, as inductor current reduces, it goes to 0. Okay, it goes to 0. And then what happens? Then obviously current becomes 0. If current becomes 0, right, current becomes 0, my T1 and T2 will be naturally commutated, because the current was flowing through T1 and T2 only. So my T1 and T2 will be naturally commutated. Why? I will write here in brackets. They will be naturally commutated So yeah, T1 T2 will be naturally commutated because current will be IT1 and IT2 will go to 0. So they will be simply naturally commutated, as there is no energy left by the inductor and everything will go to 0. What will be my VO this time? My VO, right, VO will be simply equals to E. Okay, because every current is 0, inductor current is 0, so changing current is also 0, so VL will also be 0, so IO into R will also be 0, so VO will be E only. My source current, right, source current will be 0, my load current will be 0, every current will be 0, all of them will be off right now. Okay, and again they will block the voltage in shared manner. So from pi to beta, what will happen? Basically the inductor will keep this T1 and T2 as on. Okay, it will keep the T1 and T2 as on. Then just at beta, right, the current will become 0 and T1 and T2 will be naturally commutated. So this will be basically for the second case. Okay, I mean for the case after this, not here, right, not here. So I just messed up a bit, so just hold on a second. Yeah, everything is fine. So now like when this is on, right, when this is discharging, what is the voltage? Those case will be same only like this case. Okay, VO will be equals to VS, IS will be equals to IO, but this time again power will be negative for the source power, right, so it will absorb some power and hence everything will decrease. So all this analysis will be same, just one extra case will be there when everything will be 0, IO, IS, everything will be 0. That is for the next case after this. So we'll just quickly add this here and here. Yeah. Okay, so in the next case, what is happening at omega t equals to beta. At omega t equals to beta, current is going to 0. Current is going extent. So as soon as current is going to 0, so T1 and T2 will be naturally commutated, current will go to 0, and my VO, output voltage, will be simply E, because this IO into R will be also 0 and inductor voltage will also be 0. So this will be E simply, and your input current, source current will be 0, and output current, load current will also be 0, and there will not be any power flow. Okay, there will not be power flow, everything will just stop. and what will be the voltages across the SCRs. So my, again, everything will divide, like T1 and T2 will both of them will share the reverse voltage of the Vs minus E, right? Source voltage minus the battery voltage of the output, and your Vt3 plus Vt4 will be basically equals to minus Vs minus E. So one thing to remember is that this, whatever thing I am doing the analysis on, I am talking about the negative half cycle. So in the negative half cycle, my Vs is less than 0. So if Vs is less than 0, so this whole thing is negative. So if this whole thing is negative, then I can safely say my T1 and T2 will be in the reverse blocking mode, and I can safely say that this is negative, right? This is negative, and my assumption is it is greater than E, or it can be less than E also, it doesn't matter. But overall, I can say that my T3 and T4 will be in the either in the reverse blocking mode or in the forward conduction mode. Forward blocking mode, it will reach to forward blocking mode. So these can be in the forward blocking mode or in the reverse blocking mode, I don't care. Now at pi plus alpha, what is happening? My assumption is alpha is greater than theta. Alpha is greater than theta, so it will only conduct. So this is my assumption. So alpha is greater than alpha minimum, then only it will become uncontrolled only. So my assumption is alpha, if we're analyzing the control case, right? Assumption is in this control case, my alpha will be greater than alpha minimum equals to theta. Okay, it has to be greater than theta. So that is my assumption. So if it is greater than theta, right? This T4 T3 basically will be either in the reverse blocking mode, will be either in the forward blocking mode, or will be on their way to forward blocking mode from reverse blocking mode. Okay, this is what will happen. So from pi plus alpha, again the same analysis. What is the same analysis? That this at omega t equals to pi plus alpha, my T3 and T4 are triggered. As soon as T3 and T4 are triggered, they are on, right? They are on. So my VO will be what? VO will be simply equals to minus Vs this time. You apply KVL, VO will be equals to minus Vs. My IS will be equals to minus IO. This will be equals to this thyristor current, right? Now what is your power? So what is your power? So my Vs in itself is negative, and IS is also negative, right? So IS is negative, and my Vs is also negative. So my power PS is what? PS is actually positive. It's actually positive because negative times negative is positive. Hence, obviously, power flow. What is the direction of power flow? Power flow is from source to load. It is from source to load. Okay. As it is from source to load, obviously, what will happen? My inductor will get energized. So inductor current will be increasing, and yeah, basically that is the analysis, right? Inductor current will increase, and from to what? Up until from pi plus alpha to 2 pi, because after 2 pi again what will happen? This T3 and T4 will try to go to natural commutation. My polarity of this supply voltage will change. Again, the source will become source will now absorb the power. So same condition here, that whatever I have written in this case, right? Whatever I have written, right? Inductor will change its own polarity to keep T3, the same T3 and T4 on, so that current doesn't go to 0 instantaneously, because from pi plus alpha to 2 pi, current is only increasing. Hence, obviously, it is increasing from some like value that is 0 or something. So it is some positive value at omega t equals to pi. So it can't go to instantaneously 0. So it will keep this time. It will keep T3 and T4 on. T3 and T4 on. So it keeps T3 and T4 on. So the current doesn't go to 0 instantaneously. So this is the case. Again, like there can be two cases here. One case is that it doesn't discharge, right? It doesn't discharge totally. If it doesn't discharge totally, so what will happen is up until next 2 pi plus alpha, there will be continuous conduction. Continuous conduction. So if there is continuous conduction, that means that the same process will repeat here, right? So here if I just do the analysis here again, so I will just do the analysis that my Vs in this region, Vs is positive. Vs is positive. Why? Because after 2 pi Vs is again positive, and my Is is equals to what? Is equals to minus IO. So obviously my Is is less than 0. Is is less than 0. So what is my PS? PS is basically less than 0. Okay, because product is less than 0. So this time I can safely say the direction of power flow will be from load to source. Okay, load to source. This will be the direction of the power flow. And like at omega t equals to 2 pi plus alpha, again this devices will get triggered. This T1 and T2 will get triggered. Again it will charge. But this is the case 1. Case B, what can happen is that it extends the it extends to some angle, so the current becomes 0. So this is the case where the case of discontinuous conduction. Discontinuous conduction. Okay, this is a case of discontinuous conduction. So basically what is the, again the condition is beta must be greater than pi plus beta must be less than pi plus alpha, right? Beta must be less than pi plus alpha. That is the condition. So did I wrote the condition previously? Yeah, beta must be less than pi plus alpha. So what will happen? So here, right, as they were on, so inhibitor will try to discharge, and as inhibitor discharges, so here what was the case? Yeah, this thing will be copied basically. This thing will be copied basically. Like this case will be same as the previous case only, but like these are on, right? Inhibitor will keep this T3 and T4 on. So as it keeps T3 and T4 on, basically the current this time is negative. Okay, current is negative because Is is equals to minus IO. IO is positive, but minus IO will be negative. Hence, my source will absorb some power. So power will flow from load to source, and it will completely discharge. So it will IO will reduce. As IO reduces, it will completely de-energize. Okay, so completely de-energized, hence my IO will go to 0, and as soon as my IO goes to 0, everything will be on off. This T3 and T4 will be naturally commutated. So this case, right, I will copy again this case, that this time T4 and T3 will be naturally commutated. So okay, this is the case, and as soon as they are naturally commutated, right, okay, this is from 2 pi to pi plus alpha. Okay, what did I do wrong here? Okay, this page is not for any use. This from this side, they're 0, so I will just delete this page. So as soon as they are naturally commutated, what will happen is that my T3 and T4 are naturally commutated, hence my currents, right, all the currents will go to 0. Like, why are they naturally commutated? Because the output current was 0 and the output current was equal to the thyristor currents T3 and T4, so they were naturally commutated. Okay, so obviously my output voltage will be VO will be equals to E, source current will be 0, load current will be 0. This time VT1 will be Vs minus E, but Vs is positive this time. So as Vs is positive, and I will assume that like it will go from reverse blocking mode to forward blocking mode, because I have assumed that alpha is greater than theta. So it will go from reverse blocking mode to forward blocking mode, and VT3 plus VT4 will be minus Vs minus E, and this is positive. Vs is positive, so minus times this is negative, and I'm subtracting a negative number from a negative, so obviously it will be in the reverse blocking mode. Okay, it will be in the reverse blocking mode. Okay, so T3 and T4 will go into the reverse blocking mode as they are naturally commutated. Okay, so these are the cases and these are the waveforms. So things are pretty simple here. just what you have to assume, this is for the continuous conduction. Continuous conduction is very simple. Why is it very simple? Because like it is always conducting. As it is always conducting, what will happen is that in the first half cycle from alpha, I have started with alpha, right? If from alpha, inductor changes its voltage instantaneously, because the voltage suddenly changes because the SCR turns on, right? The SCR T1 and T2 turns on, okay, in this region, and T1 T2 is on till here. Then after this, what happens is that in this region, right, at omega t equals to pi, what is happening? The source voltage is going to negative, but the current direction is still positive. Hence, the overall power is negative. Hence, in this region, power flow. What is the direction of the power flow? Direction of the power flow. If I can have some other color, I wish. What is the direction of the power flow? Direction of the power flow is from load to source. Okay, this is the direction of the power flow for this case. But in this whole region, right, in this whole region, my source voltage was positive and my source current is also positive. If you see, right, source current will also be positive. I will just come to the source current. I know that source current will be positive. Hence, the direction of the power flow will be from source to load. So, if the power flow is from source to load, obviously inductor will energize in this particular time and inductor will de-energize in a particular time. You are seeing that de-energizing time is less than energizing time, but previously I told you both of them are equal because there was no R present. Now inductor has to discharge to R, right? It has to supply the energy to the resistor and to the source, both. Previously inductor was energizing from the source and it was de-energizing to the source, okay? But there is extra R present. Due to that reason, it will de-energize faster than it will energize, okay? So I hope you understood this point and I hope you understood the voltages across T1, T2, because in continuous conduction, right, at every stage, either a natural pair will be on. So I will write here. Where can I write? I don't have any space. So I will write in the bottom here. Write in the bottom. Okay. I will write here. Continuous conduction. One natural pair, right? Natural pair means T1, T2 or T2, T3, T4. Natural pair will always be on. Okay, will always be on. So this is about the conduction, and yeah, one natural pair will always be on for continuous conduction. See here for continuous conduction. Okay, so as one natural pair will always be on, so the voltage that my thyristors will block, right, this will be directly equals to the supply voltage. They will not share any voltages because four of them will not be off at once at any particular instant. Either two of them will be off. At every instant, only two of them will be off. That's why the voltages, thyristor voltages will be directly proportional to the supply voltages because each of them are blocking the supply voltage. And here what is happening? So I have assumed exponential charging and discharging because like this is not exactly exponential. This is some non-linear function. Non-linear, right? This is not exponential. This is some non-linear function. Okay. So what is my assumption? If the current is continuous, right? If the current is continuous, it will discharge. Then it will charge from alpha to pi, then again it will discharge, it will de-energize, hence the current will reduce, energy is reducing across the inductor, so half Li square is reducing, hence I will reduce, right? So it will discharge, then again at pi plus alpha, this will again energize, then again de-energize. So these are the source current. So source current will be plus IO during the region from pi to, during the period of alpha to pi plus alpha, because here T1 and T2 are on, and from pi plus alpha to 2 pi plus alpha, here my T3 and T4 are on. As T3 and T4 are on, what will happen? Basically, it will be equals to minus IO, hence this is negative. And thyristor can never go to negative, right? Thyristor will be always positive. So from alpha to pi plus alpha, my T1 T1, T2 are conducting, hence like it is equals to my IO, and after that it is totally 0, and then again from 2 pi plus alpha to 3 pi plus 3 pi plus alpha, my T this is again conducting, right? T1, T2 is conducting. And what about T3 and T4? From pi plus alpha to 2 pi plus alpha, my T3 and T4 will conduct, so this will be directly equals to my IO. So I hope you have understood the waveforms. The interesting, like here I have written the condition. And what is the condition for continuous conduction? If, like, what is the condition for constant current? What is the condition for constant current? If my L by R, right, time constant, discharging time constant L by R is much greater than time period, then obviously current will always be constant. Why? Because it will discharge by a very small amount. As the time constant is very high, what do we mean by this? If you have studied transient well, you will understand this. Okay, so these are the waveforms. If the current is almost constant, right, almost constant, this like this will become linearized. We can linearize this. Okay, so in pulse response video I have also explained how we can linearize this. So what will the voltage? So here, right, what is happening? Current is reducing. As current is reducing, obviously inductor voltage will be negative. Okay, because it is de-energizing, and the slope is negative, hence inductor voltage will be negative. Here current is increasing. That means what? Inductor voltage will be positive because it is energizing. Okay, so and what will be the source current? Source current will be just the negative when this is in the alpha period, and from alpha to pi plus alpha this will be equals to this IO, and from pi plus alpha to 2 pi this will be simply negative. Okay, these will be the cases. These will be the basically voltages across the inductor. So can you draw the voltage? Can you draw like write the voltage expression? I cannot exactly write the voltage expression, but what I know is my VL, right? My VL, I can use some other color. My VL is, what do you know? My VL is VO minus IO into R. If this is almost linear, IO into R minus E. Okay, IO into R minus E. So what is my maximum inductor voltage? VL max. What is my maximum inductor voltage? My maximum inductor voltage will be when I have reached to, like, I don't know. Okay, so it will be basically when this VO is VM, right? Why? Because I have assumed that IO is constant. I assume IO is constant and this E is also constant. So when will I get my VL to be maximum? This is just an assumption. So this type of question can also come. So assumption is L by R is very high. If L by R is very high, I can write my VL as this expression, right? And VL maximum will be what? This is constant. IO is constant and E is also constant. R is also constant. So only VO is varying, right? What is VO? VO simply equals to VS in this region, right? From alpha to pi. So my maximum, right? It will be VM minus IO into R minus E. Okay, and what about VL minimum? VL minimum will be like this, right? This will happen, maximum will only happen from the region alpha to pi plus alpha. Okay, and minimum will only happen from pi plus alpha to 2 pi plus, or like in the positive half cycle I can write this in a better manner. In the positive half cycle, and this will only happen in the negative half cycle. Okay, okay, not actually in the exactly in the positive half cycle. Sorry, this is again wrong, because this will happen in here, right? So here some sort of in this region, so it is combination of both positive and negative. So this, I hope you understood what do we mean by this. So when will this be minimum? This will be minus VM minus IO into R, because IO is constant, minus E. Okay, so this will be the minimum value. And why did I say that discharging time will be lower than the charging time? Because if you see, right, my magnitude of VL minimum when it is discharging, right, when it is discharging is greater than VL maximum. Why magnitude is more? If you observe here, I am subtracting I'm subtracting a positive value. Sorry, I am subtracting from a positive value this IO minus R into minus E, and this is already negative, and I am subtracting even more negative. So it will be more negative. So magnitude will be greater. So it will discharge faster. So what, like this, from this I can conclude, what do I want to conclude is it will discharge faster. That's why it is discharging faster. So you can understand from here as well that why is it discharging faster. This means it will faster. Discharge fast, right? Okay, so this is the case. This is the case for the continuous case. And what about the discontinuous case? So for the discontinuous case, right, I will not draw the thyristor voltage. It will be just complex. Okay, just the load currents and source currents and the output voltage. So in case of discontinuous case, right, whenever this is getting discontinuous at beta, at some extension angle beta. So here it was discharging and it totally discharged current totally went to 0 at this extension angle beta. Then as current is 0, what will happen is that my voltage will instantly go to E. Okay, it will be constant at E, and then again it will remain constant at E, and then again at pi plus alpha, what will happen? This will be triggered, and again it will charge, and then again it will discharge, and then again it will be E, then again charge and discharge. So source current from alpha to pi it will increase, then from pi to beta it will decrease and decrease totally to 0, then it will remain at 0. From beta to pi plus alpha, then from pi plus alpha to 2pi, again it will increase and again it will continue. Okay, and source current for this positive cycle, this will be positive, and for this negative cycle it will be simply negative. Okay, so these are the cases, these are the things that you need to understand here. And in this region, right, T1 and T2 will be on, and in this particular region from beta to pi plus alpha, all will be off. Okay, all SCRs will be off, all off. Here as well, all are off. Okay, so from in this region, right, so previously all were never off, at least one natural pair was on. Here one natural pair is off, like all 4 SCRs are off for pi plus alpha minus beta duration. Okay, that is the duration. So if beta is equals to pi plus alpha, that means I am on the edge of or on the boundary of continuity and discontinuity. Continuity and discontinuity, basically continuous and discontinuous conduction. Okay, so that is the case. So like one thing you can do is, one condition you should know. So this numerical come from this condition, that like this cycle, what is this cycle? From alpha to pi plus alpha. So from alpha to pi plus alpha, what can I say is I am completing a cycle. So I know, right, I know my VL average will be 0, because as it is a stable circuit, VL average will be 0 according to the volt second criteria. So if I integrate my VL average, if I integrate my VL of t, d omega t from alpha to pi plus alpha, I will get 0. So if I just do one thing is that my VL, right, if I have discontinuous conduction, what does that mean? That this will be only alpha to pi only, or no, this is fine. So here, right, what I will do is I will expand my VL expression. So what is my VL expression? This is integration from alpha to pi plus alpha. What is VL of t? VL of t is Vs minus IO into R minus E. Okay, d omega t should be equal to 0. So this is a good relation that you should know. Is like this can help you solve a numerical. So this, they can frame a question according to this numerical. So this is not a formula. This is the volt second criteria, right? Don't remember it as a formula. Just remember these type of questions they can also frame with the average voltage of the inductor. Okay, so they can frame the question like this. So rest is pretty simple, right? So again, average output voltage for continuous conduction will be what? From alpha to pi plus alpha, my VO is equal to simply Vs. I will replace that and I will get 2 Vm upon cos alpha. So do you need to remember this? No, right? You know what is happening in the conductor. So you just write this and derive. It will take you 10 seconds. So that's fine. That's fine. IO average, no need to remember. Just remember VO average minus E by R. Okay, just like that. Then what is average output voltage? Average output voltage for discontinuous conduction, right? If my beta is between pi to pi plus alpha, beta needs to be between pi to pi plus alpha, then only there will be discontinuous conduction. So here, what will happen is that for alpha to beta, it is on. So the thyristors are on, hence my VO will be equal to simply Vs. So I will integrate from alpha to beta, and from beta to pi plus alpha, what will happen? My thyristors will be off, so output voltage will be simply equal to T. So if we integrate, I will get this formula back. Okay, so all these are self-explanatory. I don't need to explain much here, right? One thing is important for continuous conduction, right? For discontinuous conduction, they won't ask you the RMS voltage, but for continuous conduction, what will happen is that VO RMS will be simply equals to my VS RMS. This will be simply equals to VS RMS, because why? My VO square, right? My VO square is always equals to Vs square. If you notice carefully, Vu is either equals to plus Vs or minus Vs. If I square them, the negative sign goes away, right? So obviously my Vu square is always equals to Vs square, and when the squares are equal, right, the RMS values will also be equal, because what is RMS? RMS is basically the mean of the square, root of the mean of the square of the particular expression. Okay, so that's why this will be Vm by root 2, pretty simple. And then converter efficiency, these things you already know, right? I don't need to explain all this. And voltage current for supply again, the source average current won't be equals to the average load current. Obviously the source RMS voltage will be Vm by 2. This is independent. And again I am happy. Why am I happy? Because my IS, if you just see the graphs, right, my IS average will again come out to be 0. So there is again no DC component. That's why we use this, because this doesn't give any harmonics to the supply end. Okay, so this is what is happening. And again the RMS values are equal. Why? Because either my source current either is equals to load current or it is negative of the load current. So if I square them, again IS square equals to IS square. Hence if squares are equal, then my RMS values will also be equal. Power factor, again, if the converter is ideal, PS will be equals to PO. And we will do a few numericals on non-ideal converters as well. Don't worry about that. PS will be equals to PO. And what is PO? PO is IO RMS whole square plus into R plus E into IO average. Okay, and this is simply VS average into IS average. Now, what is the conduction period for each SCR? Conduction period for each SCR, if they are on, if there is a continuous conduction, my T on will be simply pi by omega. This will be my on period of each SCR. And natural commutation period, again, from pi plus alpha to pi plus alpha. What is happening? Okay, sorry. From here, right? Natural commutation period means for what duration the voltage is negative. So voltage is negative in this duration, right? If you observe, voltage is negative in this duration. What is the duration? Pi plus alpha to pi. Basically after pi the voltage becomes positive, so they come into the forward blocking mode. So pi plus alpha minus lower limit, upper limit minus lower, that is pi minus pi plus alpha. Sorry, this is 2 pi, right? Here 2 pi. So 2 pi minus pi plus alpha, this will be pi minus alpha, and exactly that is what is written over here. Okay, this will be the natural commutation period, and peak inverse voltage will be Vm, because if you observe the plots, you will see if there is a continuous conduction, right? So other SCR will come across the Vm, so that will be the peak inverse voltage. Now constant load current. What is the condition for constant load current? If my L by R is very larger than the time period, if the L by R is very larger than the time period, then it will discharge very slow, then everything will be equal. My IO average will be equals to IO RMS, will be equals to IS RMS, or will be equals to my IO maximum, will be equals to my IO minimum, will be equals to VO average minus E by R, will be equals to, what is VO average? 2 Vm upon cos alpha by R. So this is mostly what we assume. Okay, they will tell you in the question, don't worry. And what will be the average thyristor current if everything is constant? If everything is constant, then the thyristor will conduct for a pi period of time, each thyristor, okay, over a 2 pi period. Okay, so here, right, each thyristor for what duration does each thyristor conduct? Each thyristor conducts total pi from alpha to pi plus alpha, total pi. And what is the cycle? What is the repetition cycle? After every 2 pi it repeats. That's why divided by 2 pi, total time into area. What is the area? Area is IO into pi. IO into pi is the area of the rectangle. So area upon the total time period is the average, gives us the mean. So that's why this is IO upon 2, and IO RMS, IT RMS will be root 2, because why? I take the under root. Okay, I take the under root. Pi into pi, IO square into pi divided by 2 pi. Pi gets cancelled. IO square divided by 2 under root. So that becomes IO by root. If you know how to compute RMS, you will understand this. Cos phi s is VO average by VS RMS. So this, many people remember this as a formula, 0.9 cos alpha, but you should know how this came up, right? If there is this is only valid for constant load current, right? This is always not valid. Only valid for constant load current. Okay, not always valid. So you have to take care of this as well, that your power factor will be 0.9 cos alpha. This is a formula that many people, you will see short notes of many people, but only valid when the load current is constant. This is for a full wave rectifier with RLE load. Okay, RLE load. Okay, So many people remember point and cos alpha. So like you can remember, but you can derive as well, right? It is like what happens is my IS average, right? My IO RMS and IS RMS becomes equal, so they get cancelled out. Only I am remain with VO average and VS RMS. Why? Because the PO is what? PO is purely DC power, which is VO average into IO average. So VO average into IO average is in the numerator, and in the denominator I have VS RMS into IS RMS. Okay, the apparent power. So IO average and IS RMS are equal, so they get cancelled. Only I am remained with VO average upon VS RMS, and I know the formula VO average. What is it? It is 2 VM upon cos alpha. So if I just do the computation, you will get it as 0.9 cos alpha. Okay, and like obviously the region of converter for this particular converter, right? It is both motoring and braking mode. Motoring means where my load is, power flow is absorbing. So power absorbing power. Absorbing power. And braking mode, like machine people, electrical machine people will understand what do you mean by braking mode. Here what happens is it delivers some power to the source. Okay, and we have to be careful that it doesn't deliver too much of power that can damage the supply end as well. Okay, so this thing is for electrical machines. Who have studied electrical machines, they will understand what do I mean by this coherent operation. Okay, so that's it for this lecture. So we actually learned a lot of things in this lecture, and like if at some point you had a bit of confusion, you can always repeat and go through it again and watch again, right? And you can obviously always ask in our doubt group if you have any more doubts. Okay, so I hope you enjoyed this lecture, because we learned a lot of concepts, and trust me, no one teaches in this way. The analysis that I did, right, no one analyzes a circuit like this. Trust me, you can see any other lectures, you will observe over there, right? So that's it for this lecture, and in the next lecture we'll do questions of all the full wave rectifiers and also few half wave rectifiers. We'll finish the questions, then in the next lecture we'll do the assignment question, and after that we'll start with semi converters. Okay, what is semi converters, why do we need them, and what are the features of those, that we'll learn. Okay, thank you for watching, and I will see you in the next lecture.